Hello and welcome to my standard access list tutorial. In this tutorial, I will be going over a standard access list and extended access list that are established. So, an overview real quick of what an access list is. It is a rule that can be used to filter traffic across the router. So, in our scenario, we're going to have two networks interconnected with the router, and we are going to mess with interfaces to, be able to filter out what's going to be allowed through and whatnot. So let me go ahead and just go ahead and start creating these networks so you can get a better idea of what I'm talking about. So let's have this so we could tell the networks apart a little better. Okay. All right. So in this network, we are going to have an FTP server, a PC, a switch, and lastly, a router. Let's use this one. Okay, here we're also going to have another router. Another switch. Here we're going to have two PCs instead. An email router and an HTTP router. Okay, so we are go ahead and start giving them IP addresses to keep better track of what we're dealing with. We'll go ahead and use this, and this is going to be our router. So its gateway should be, let's give it 192.168.1.1. Okay. Be our FTP server, which will give an IP address of 192.168.1.254. And its IP address was 101, I believe. 192.168.1.1. Okay. And then when we configure this, so for our 0, 0, it's going to be 192.168.3.1. And for the other port, it's going to be 192.168.1.1. Okay, and then for the static route, go ahead and add 192.168.2.0, 255, 255, 255.0. And the hop is going to be towards our next router, which will go ahead and say 168.3.2. Okay, add that. Everything is good. Before I forget, go ahead and turn these on. Alright, so when we start intertwining each of these things, should start working. Okay. Okay, so for this one, its first port is gonna have 192.168.3.2. And the first port 192.168.2.1. Okay, then the static route is going to be 192.168.1.0, 255.255.255.0. Our hop is going to be 192.168.3.1. Okay. That's good. All right. And then we'll go ahead and call this one 2.100. That one, the gateway. 101. And gateway to that one. Okay, so far so good. And our email server is gonna have an IP address of 2.253. Do that one. HTTP, better yet, web. 4. IP. Okay, that should be about it. Start interconnecting each of these. Oops. Everything seems to be going nicely. Okay, so this seems to be running about correctly. Let's go ahead and ping some within that network just to be sure everything's running fine. Okay, now from the other network, might take a while to get a response. Oh, I'm pinging the incorrect computer. And there it is. Okay, so everything's set up properly. We could reach that way, and just to verify that you could also, network B could reach network A. Let's go ahead and check network A could reach network B. 92.168.2.100. Okay, awesome. Network A, network B. Oh, oops. Alright, let me just rename them real quick. Network A. Actually, that's a better placement. Let's go put them over here. Network B. Cool. Okay. So for our first scenario, well, let me go ahead and give you a little bit more detailed what access lists are. So, as I mentioned earlier, it's basically like a set of rules that can be allowed to filter what could, what, depending on how you customize it, you could either permit or deny specific source IP addresses from going in or out of your network. So first thing I'm going to go over is the standard access list, which uses the custom numbers 1 through 99, and it is applied closest to the destination. And for the extended access list, it uses numbers 100 through 199, and it is applied closest to the source. And the difference between the standard and extended is that extended, I guess you could say, accepts more parameters. It not only denies / permits source IP address, it also you could also include this destination address and the port service. So let's go ahead and just to mention real quick, this could be like your own type of like little firewall that you could use this access list for. Anyway, back to the scenarios I'm going to go over. First scenario is I'm going to allow all devices from this network, but one of them to be allowed to reach anybody from network A. So, since I'm trying to cut off the connection from this source to this one, this is our main source and this is our destination, correct? Since I'm trying to edit this one to reach this. And the way, like I mentioned, standard access list works, you have to apply it to the interface closest to the destination. So between these two interfaces, this one is closer. And a step beyond that is this is considered inbound and outbound. So closer to the destination, as you can see, will be considered the outbound of this interface. So we will apply it here. Go ahead and start new. So first things first, we need to create an access list. The way you do that is you go to conft, and from there you put this command, access list. Remember, it has to be 1 through 99, so we'll go ahead and use number 1, and we'll go ahead and deny this PC from reaching this network. So go ahead and deny 192.168.2.100, and then you add the wildcard subnet mask. You could either have it like this or deny host 192.168.2.101. Either way is fine. So let's go back to where we had it, because for a bit more information, when you have it this way, when you add the wildcards, this is for the host alone, and this is for the entire network, which will implement something similar to this in a short time, a little bit later. So, okay. And then afterwards, you have to say access one permit any. And the reason why for this, I'll mention a bit later. This is actually coming really useful for our second scenario. So let's go ahead and just add that real quick. Okay, so that would be our created um, access list. Now we have to apply it. And the way you do that is you go to the interface through the command. So it's fa0/1. Okay, and then access group our list, which we use number one. And here you put it was either outbound or inbound. And as we mentioned, closer to the destination is our outbound. Okay, so if we go ahead and test our scenario, all these should be able to be reachable except for this one. So as we saw a minute ago, okay, so let's go ahead and first check this one, 168.1.100. Okay, that PC was able to reach this PC no problem. Now this one, as you saw before, it was able to reach it. Now let's go ahead and see if it still can. Okay, so our access list was successful. It wasn't able to reach that certain piece network. And the cool part is though, when this PC tries to go reach that same PC, it also it gets a request timeout, not like before where packets got sent back. So what happened here was this PC has no problem reaching this network and getting the PC, but when it starts to reply, it gets held back right here. It gets stopped. So everything else should be fine. Go ahead and test one of the servers, 192.168.2.253. Okay, everything's successful. So as you can see, this is the only one not able to leave the network, just to be sure that he can reach its buddy next to him. 2101. Okay, cool. So yeah, he's just not able to get past this guy and go towards over here. Okay, so that was our first scenario. Now we're going to deny all hosts from network B to reach network A. And there's quite a catch to this implementation actually. So first things first, let's go ahead and remove our access list first. So the way you do that is first you go to the same way you implement it and just put no access lists and the number that we made. Okay, so our list should be no more. Just to be sure, let's go ahead and be sure this guy is out of timeout. Okay, cool. So everything's back to normal. We're all friends again. So deny host from network B. So again, this is our source and destination. So same rules apply. You have to put it inbound on this interface. So okay, we're already here. Now we create the list first of all. Remember, access list. Let's go ahead and use number 2 this time. And okay, so here's the catch. We're going to permit 192.168.2.200. The reason why we can't just create the list and implement it, it has to have something by default. So we'll just implement something that's not in there. Okay, and remember how I mentioned earlier that you always have to have a access list uh, permit any. So this time we're not going to add that. So that's our list, and now we're going to go ahead and apply it. So let's go ahead and go into that interface. This one, IP access group one, and again outbound. Ooh, we're not using the one anymore. We created a two. Okay, everything should be fine after that. Now Control C. Okay, so when we try to reach that network now, ping 2.101. Right, so we're reaching this one. So what happened? As we did not specify deny that certain IP. We didn't specify deny any. We didn't say anything to deny anything. We just denied one specific host that wasn't allowed, was not even here, or permit anybody that wasn't even here. Either way, we didn't say any specific permit. So when we try to reach that same server 192.168 dot 2.253. Also, let's time out. So the catch here is whenever you create an access list, towards the very end of that list, implicitly there is going to be an access list, your number, deny any at the very end. So if you don't have that permit any somewhere in there, it will automatically deny or have all the general commands you put at first and then deny everything else at the end. So this is why all of these can't go into this network. So something really important to remember. Now let's go ahead and conf t, go ahead and remove that. So no access list 2. Alright, so our list has been removed. We should be able to be off friends again. Okay. Now for our first extended access list scenario, we're going to allow all PCs only. So this is going to be our source and destination, right? So the way extended lists work is this you apply it to the closest to the source. So it's going to be literally the exact opposite. So destination source is going to be applied to this router and inbound this time. So let's go ahead and test that real quick. Oh. Same domain server. No idea what happened. Code is now available. Let's go ahead and take away that real quick. Not sure what I did there. Okay, so 1841. Go ahead and fix this real quick. Okay. just as we did before. 0.192.168.3.2. 192.168.2.1. And lastly, a static network 192.168.1.0, 255, 255, 255.0, and the hop is 192.168.3.1. Okay. All right, sorry about that. So back to what we're doing. All right, so we're going to allow the servers only to be reachable and not the PCs. So the way we do that is, okay, we're conft access list, and remember it has to be from 100 to 199. So in our case, let's go ahead and use 100, and we're going to deny 192.168.2.100 0.0.0.0, the wildcard bits. That's our source, and destination is going to be our network 192.16 network A. I'm sorry, 168.1.0 and 0.0.0. And for networks, you put 255.3 in. Access is deny 192. Input and validate the dark marker. Deny. Oh, sorry, forgot. You could put IP or TCP, but let's go ahead and just put IP. Okay. So we're denying that specific PC, and go ahead and deny that other PC also from reaching that server. Okay. And since we created it, it's 100 permit IP. And again, remember we have to put permit any. Keep forgetting the IP. 100 permit IP any. Okay. Because if not, by default, it's going to reject everything else. So now we go ahead and go into our interface. That's one. IP access group 100. Inbound this time. Okay. We go ahead and test our new extended access list. And okay, so these should not be able to go to that network. Okay, so as you can see, it has timed out. It's not allowed to leave this range right here. It's not being allowed to go through. And this one should not be able to either. Okay. And the server ping 192.168.1.100. The server is allowed. Likewise, when you go to its URL 168.2.253, you can reach it. Everything's fine. So PCs are allowed, servers are allowed. Okay, and what if this time we want the servers to only be allowed when requested? So in other words, I could access the website here, but the server itself can't, ping over here, can't reach, it's unreachable. So a way to do that is adding this keyword, established. So let's go ahead and show you that real quick as our last little scenario. Again, it's same scenario since it has to be inbound and closer to the destination because it is an extended list. So, but first things first, go ahead and remove our current access list. So no access list 100. Okay, and then we create our new one. Access list. Let's go ahead and call it 101. And here we are going to say 192. Let's say permit TCP or IP, either way. CP 192.168.2.254. 0.0.0.0, and our destination, which is our other network, 192.168.1.0, 0.0.0.255. Okay. Oh, forgot to add the keyword established. So let me go ahead and remove that one real quick. Okay. Generate a new one. Established. Okay, cool. Now we're allowed that server. Let's go ahead and allow the other server as well, 253. Okay. And then we'll leave it alone as at that because we still don't want these two to be able to reach this network. So we're done with our list. Go ahead and implement it. Int fa 0-1 IP access group 100 and 101 and inbound. Okay, so this should again still be unreachable. It should time out. Cool. So this should be the same. I'm gonna go ahead and bother with that. Now for this specific scenario, ping 192.168.1.100. And this is, whoa, what happened? Unreachable, the way we wanted it to. So before it was allowed to go into this network, but the keyword established only let it when this was required for it to reply. So in other words, let's go ahead and go through real quick. 192.168.2.253. I'm still allowed to go. He's still allowed to access this. So it's only allowed to reconnect or cross over when when it's requiring its information. So allow servers only established. So if you want to go ahead and run the other one as well, 192.168.2.254, and it's also reachable. So the servers I will reach are reachable, and the servers can't reach over here, and as well as PCs also aren't allowed to this network. And that concludes my tutorial on standard access lists. Thank you.